소프트웨어 등록 진행 중. 카메라를 향해 웃어주세요. 등록이 완료되었습니다. 게임이 지금 시작됩니다.
Hello and welcome everyone. We from Group B4 will present integration by parts, which is a subtopic of the topic integration. Integration by parts is a technique for integrating products or functions. In this section, you will learn to recognize when it is appropriate to use the technique and have the opportunity to practice using it for finding both definite and indefinite integrals. At the end of this video, we should be able to decide when it is appropriate to use the method known as integration by parts, apply the formula for integration by parts to definite and indefinite integrals, and perform integration by parts repeatedly if appropriate. This video contains 4 sections, which is Introduction, Repeated Integration by Parts, Another Introduction, Guidelines for Integration by Parts, Examples and Exercise.
Repeated integration by parts. It is occasionally necessary to use integration by parts more than once in the same problem. If the final integral is similar to the original, another integration by parts will be used to solve the problem. This is an example regarding to the problem. The last integral is similar to the original, except that we have replaced x squared by s. Another integration by parts apply to integrate s e to the power of negative s ds will complete the problem. The integral in the form integrate px fx dx, where px is a polynomial, can be evaluated by parts in which u is taken to be px, or one of its derivatives at each stage. Because du is calculated by differentiating u, repeated differentiation of px will finally result in 0, leaving us with a simpler integration problem. Tabular integration by parts is a useful way for grouping computations into 2 columns. Tabular integration by parts. Step 1. Differentiate px until it equals 0, then record the result in the first column. Repeat the integration of fx and record the result in the second column. Step 3. Make an arrow from each entry in the first column to the entry in the second column 1 row below. Step 4. Starting with a positive. Label the arrow with alternating positive and negative marks. Step 5. Form the product of the expression at the tip and tail of each arrow. Then multiply that product by positive 1 or negative 1, depending on the arrow sign. To find the integral value, add the result together.
Here is guidelines for integration by parts. the most important thing in integration by part is we must good in choosing u and dv to obtain a new integral that is easier to evaluate than the original. Next is the strategy that often works when choosing u and dv are: first, we must choose u that can be simpler when differentiated. Second, we must choose dv that can be integrated to obtain v. According to that strategy, we can use Lie method, which is a strategy that can be applied when choosing for u and v. So, what is Lie method? Let me introduce to you. Lie is an acronym for L is stand for logarithmic, I for inverse trigonometric, A for algebraic, T for trigonometric, and E for exponential. For example, Lie works when we find this type of questions. For this question, x acts as algebraic while cosine acts as a trigonometric. Since algebraic comes first then trigonometric in Lie method, so we let u as x dx while we let dv as a cosine x. Next is reduction formulas. Integration by parts also can use reduction formulas. There are two types of reduction formulas. One is for sin x power of n and the other one is cosine x power of n. This formula can be used if n is a positive integer and n more than or equal to 2. For your information, these two reduction formulas are derived from integration by parts. To illustrate how one of the formula can be obtained, let us derive from cosine x power of n. First, we begin by writing cosine x power of n as cosine x power of n minus 1 times cosine x, so that it will be like this. From that, we can apply Lie method to determine u and dv. From u, we differentiate cosine x power of n minus 1, and from dv, we integrate cosine x dx, so that we can write it into this formula and solve it one by one. Lastly, by moving the last form on the right to the left side, so that it will yield reduction formula for cosine x power of n.
Hello, my name is Monur Aisha binti Mirzan Abidin. Now let's move on to the example. Let's say we have integral of x squared e power of x dx. So let's begin by writing the formula integral of u dv equal to uv minus integral of v du. Now, we need to identify which one is u and which one is dv. I prefer make u is x squared and dv is e power of x dx. du is going to be 2x dx. And once we integrate dv, it's going to stay the same. So when we substitute in the formula, we get x squared times ex minus integral of ex 2x dx. We need to use integration by part one more time to find here. I going to make here is dx and dv is e power of x dx. Du is going to be 2 dx and integral of dv is simply ex. So we're going to have x squared ex minus 2x ex minus integral 2 ex dx. Now let's begin by distributing the negative. This is going to be x squared ex minus 2x ex plus 2 integral ex dx. And then we have x squared ex minus 2x ex plus 2 ex plus c. Now, if we want to factor out the ex, our final answer is going to be ex open bracket x squared minus 2x plus 2 close bracket plus c. That's all from me. Thank you.
I will continue with the exercise. So we got 4 questions at here. I will show you the question 1 and 2. For the question 3 and 4, you can try it by yourself. And the answers are given at there. So for this question, we need to decide which one u and which one dv. So by using the order lineage. So for this question, x is in the category of the algebraic, while arctan x is in the category of inverse trigonometry. So by using this order, this one comes first, after that algebraic. So we can label the first one as u and the second one is dv. We take out the information. So for this one, we need to differentiate both sides. So we got du equal to 1 over 1 plus x squared. How we can like this? You can find it in the reference book or the internet. So for the second one, we need to integrate both sides. So we got, after we have all of these informations, we need to fill it in this formula. After that, so u multiply with v and then v multiply with du. And then at there, we have constant 1 over 2. So we can take out the 1 over 2 at there. So for this fraction, it's quite tricky to integrate it, but we can separate them into 2 fractions, which is plus 1, minus 1. So we got this one, and then we can cancel out for the first fraction, which is x squared plus 1 over 1 plus x squared, and then we integrate 1, we got x. And then we integrate 1 over 1 plus x squared, we got arctan x. So the final answer is 1 over 2 x squared arctan x minus x plus arctan x. Don't forget the plus c because we don't have limits in these questions. For the question 2, we also need to decide which one u and which one dv. So for this question, x squared is in the category of algebraic A, while ln x is in the category of logarithmic L. So by following this order, the logarithmic is come first and then followed by algebraic. So the first one we label as u and the second one we label as dv. So let's take out the information. The first one, we need to differentiate both sides. We got du equal to 1 over x.
And then the second one, we need to integrate both sides, which is v equal to x cubed over 3. So after we got all of this information, we need to fill in this formula. So 1 over x dx, while we differentiate log x, we have to put 1 over x dx. So x cubed we can cancel out with x. So we have constant 1 over 3 at there, so we can take out the 1 over 3. So if we integrate x squared dx, we have x cubed over 3. Don't forget the plus c because we didn't put the limits yet. We need to substitute the value of Euler and 1. After we substitute the both values, we can solve it as usual. So the final answer is 2 Euler power of 3 plus 1 over 9.
That's all from us from Group B4. I hope you enjoy and thanks for watching.